Welcome to Powered by Tesla.
You know, they power our world, from the trains we ride to the mills that forge our steel. But they often go completely unnoticed. So today, we're going to pull back the curtain on an unsung hero of modern industry, the direct current motor, or as you know it, the DC motor.
All right, so you've got to ask the question, right? We live in a world where pretty much every wall socket gives us alternating current, AC power. So it's easy to think the DC motor is just some relic of a bygone era. But is that really the case?
Not even close. Seriously. DC motors are the absolute beasts behind some of our heaviest industries. That incredible torque you need to get an electric train moving, the sheer brute force for a steel mill, the heavy lifting of cranes and elevators, yeah, that's the home turf of the DC motor. They are so far from obsolete, they are essential. So how in the world do these industrial giants actually work? Well, it all boils down to this one fundamental principle of physics. It's kind of like magic, the way it turns pure electricity into raw motion. This is it. This is the whole secret sauce. It's this simple, elegant idea that everything else is built on. You run an electric current through a wire, you put that wire inside a magnetic field, and the wire gets pushed. That's it. That little push, that mechanical force, is the secret to the entire operation. Let's walk through it, step by step. First, you use power to create a magnetic field. Easy enough. Step 2, you send more current through a bunch of wires that are wrapped around this central rotating part. That's called the armature. And then, step 3, the magic happens. That interaction between the current and the magnetic field creates a force on every single one of those wires, and all those tiny pushes add up to create one powerful, spinning torque that makes the whole thing go round. Okay, but think about it. If you just dump a ton of current into the motor when you turn it on, you're going to fry it. So how does it protect itself? Well, this is where a really cool internal mechanism comes into play. It's like a hidden brain inside the motor, and it's called back E.M.F. And this is the critical problem, isn't it? The second you flip that switch, the motor's resistance is super low, and all that current just wants to flood in at dangerous levels. So what's the safety valve here? The answer is back E.M.F. You see, as that armature starts spinning inside the magnetic field, it actually starts acting like a tiny generator all on its own. It creates its own voltage. And this back voltage, or electromotive force, literally pushes against the voltage coming in from the power supply. It acts like a natural brake on the current. Now look at this, because this visualizes the balancing act perfectly. At startup, right, the speed is low, so the back E.M.F. is also low. This lets a huge rush of current flow in, which is exactly what you need for that massive starting torque. But as the motor gets up to full speed, the back E.M.F. skyrockets, almost matching the supply voltage, and that automatically throttles the current way down to a safe, super efficient level. It's brilliant. And that's the key takeaway right there. Back E.M.F. turns the DC motor into a smart, self-regulating machine. It just automatically knows to draw only the current it needs to do the job. It protects itself and runs efficiently, all without needing a bunch of complicated external controls. Okay, so now that we get the basic idea, let's meet the family. Because not all DC motors are created equal. They basically come in 3 distinct personalities, and each one is perfectly tailored for a specific kind of job. And this table lays them out perfectly. You've got the shunt, the series, and the compound motor. And to make it really easy to remember, I love this analogy. Think of the shunt motor as a marathon runner, all about steady, constant speed. The series motor, that's your weightlifter, built for just pure explosive starting strength. And the compound motor is the decathlete, a versatile all-rounder that's good at a bit of everything. So first up, we've got our marathon runner. The defining trait of a shunt motor is its uncanny ability to maintain at almost constant speed. Doesn't matter if it's got a light load or a heavy one. It's built for endurance and, above all, consistency. Next is the weightlifter. And let me tell you, the series motor is the undisputed champ of starting torque. It can get ridiculously heavy things moving from a dead stop. But here's the trade-off. Its speed is totally dependent on the load. The heavier the load, the slower it's going to spin. And finally, our decathlete. The compound motor is basically a hybrid, right? It combines features from the other two. It gives you a really strong starting torque, way better than a shunt, but with much more stable speed control than you'd get from a series motor. It's the perfect balanced choice for those demanding, variable jobs. So we have our three athletes. Now let's see where they actually compete. Where do you find them out in the real world, putting in the work? Our shunt motor, the marathon runner with its constant speed, is perfect for anything that demands precision. You'll find it in machine tools like lathes and drills, or in textile machinery. Things where a consistent, unwavering speed is absolutely critical for a quality result.
And the series motor, the weightlifter, with its massive starting torque, well, that makes it the only real choice for the heaviest of heavy jobs. Getting a train moving, lifting a shipping container with a crane, hoisting an elevator, all of those require that insane initial burst of power that only a series motor can deliver.
And what about our versatile compound motor? It gets put to work in machines that face irregular, heavy, or really sudden loads. Think about industrial presses and shears that need to deliver a powerful hit and then recover quickly. The compound motor gives them the torque they need without letting the speed get totally out of control. So, when you put it all together, it's pretty clear. Far from being obsolete, DC motors, in all their different forms, are the powerful, intelligent, and absolutely essential workhorses that are driving the engines of our industrial world, mostly hidden just out of sight. It really leaves you with a final thought, doesn't it? What other seemingly old technologies are out there, just like the DC motor, still secretly holding our modern world together?
Like and share this video. And don't forget to subscribe to Powered by Tesla.